Hello, this is the Project 1 video for Parker Brandt and Landon Perez for Dr. Ozbay's Fluid Mechanics class in summer 2025. So the first thing we're going to do is create the sketch of our pipe. So we're going to click on Fluid Flow, Fluent, and drag it over to the right. We're going to click on Geometry and change the analysis type from 3D to 2D. And then right click on Geometry and select New Design Modeler Geometry. So to sketch our rectangle, we're going to click on Sketching, select Rectangle, and then click on the origin and click again. Then we're going to change our units from meter to millimeter, and we're going to click on Dimensions, and we'll click on Vertical. And then we're going to click on Length and create a horizontal dimension. So for our height, I'm going to change it to 10 millimeters, and our length is going to be 1500. Zoom in here. Next, we're going to select Concept at the top and select Surfaces from Sketches. Change this to a box select. And then we're going to click Apply. And then we're going to select Generate. And that creates a surface. Now we're going to go back to the workbench and double click on Mesh. So after double clicking on Mesh, this new window pops up. And we're going to come up here and click on Edge. We're going to name all four edges. So we're going to start with the top one. Right click, come down to the bottom, create name selection, and it's going to be called upper wall. And then do the same for the remaining edges. Bottom one will be called lowered wall. And the right edge will be called inlet. And the right edge will be called outlet. And you can see all four name selections on the left. Next, we're going to right click on mesh, insert, sizing. We're going to make sure edge is selected, otherwise it might highlight the whole body. And we're going to hold control down and select both the top and the bottom edges, the upper wall and the lower wall. We're going to select geometry and apply, and it should pop up like this. Then we're going to change the type from element size to number of divisions. And we're going to set the number of divisions to 2500. And then we're going to change capture curvature to no. And we're going to change the behavior to hard up here. And then we're going to click generate. And it might take a little. So now that our first mesh is created, we can click on mesh and we can see it if we zoom in. We're going to go ahead and create a second mesh. So we're going to right click on mesh, insert, sizing. We're going to hold control and we're going to select the other two edges, the inlet and the outlet. We're going to go ahead and click apply. We're going to change the type from element size to number of divisions. And instead of 2500 this time, we're just going to do 50. And then we're going to change the capture curvature to no. Oh, keep doing that. And we're going to change the behavior from soft to hard. And then we're going to click generate. Now we're going to go back to our workbench and we're going to right click on mesh and select update. And once you have a green check mark, you can double click on setup. And we're going to want to make sure double precision is selected, and then you can click start. Wait for this to load. Select OK. And then the first thing we're going to do is we're going to go to models, and we're going to want to make sure that this, whatever this is, this flow, we want it to be laminar. Next, we're going to click on results, and we're going to click on residuals. And I'm going to change this to 1e to the -6. And then I'm going to select OK. Next, I'm going to click the drop down on materials and then fluid, and then double click air. And I'm going to change the density here to 1. And I'm changing the viscosity to 1e to the -5. Change and create. And then close. Next, I'm going to double click on reference values. And I'm going to select this to compute from the inlet. And then I'm going to change the reference zone to surface body. And then also make sure that the density and viscosity are the same as what you just entered. Next, I'm going to select the drop down on boundary conditions. And I'm going to select inlet and then double click. And then I'm changing my velocity magnitude to 0.04 meters per second and click apply. Then I'm going to select the drop down for outlet and double click there. And I'm going to select the checkbox for prevent reverse flow. Click apply and then close. Next, because this is Poisson flow, we're going to want to make sure that our top and bottom walls are stationary. So we're going to click the drop down on wall and make sure that this is stationary and no slip. Make sure those are selected for both walls. Okay. And then I'm just going to double check the reference values to make sure this is what we entered. Yep. And then I'm going to double click on initialize and then click initialize. And once this is done, you're going to come down here to run calculation. You're going to double click it. I'm going to change my number of iterations to 500. And then I'm going to click calculate. And then once the calculation is complete, I'm going to go back to Workbench and I'm going to double click on results. Okay, once this comes up, I'm going to click on location in the top and I'm going to select line and I'm going to name this midline. Click OK. And you're going to want this to be whatever half your length is. So my length was a meter and a half. So this is going to be 0.075 or 0.750 meters. Same for here. And then this is going to be your full width. So mine was 10 millimeters. So that's going to be there. And then I'm going to click apply. Oh, that should be 0.01. And you can see right there, that's our midline. I'm going to click location again, and this is going to be the end line. And I want this to be as far to the right as possible without actually being on the edge of the rectangle. So I'm going to put 1.4999. And my total length is a meter and a half. And then this once again is going to be your width. And click apply. And you can sort of see down here there's a yellow line. Next, I'm going to click location one more time and name this developing flow. Click OK. And I'm going to change my X value to 45 millimeters. And this once again is the 10 millimeters. And you can see that right here. Next, I'm going to go to the top and select insert or just contour. And it's just going to be named contour 1. And I'm changing the location to symmetry 1. And I'm changing the variable from pressure to velocity u. And then I'm going to change the number of contours to 110 and then click apply. And you can see we get a contour here with our legend kind of in the way. So we can click on default legend, change it to horizontal, and the appearance to scientific, and then it moves up to the top. Next, I'm going to click on chart, and I'm going to click on insert chart. It's going to be named chart 1. We can change the title to pursue, or I guess velocity profile. And then I'm going to go to the data series and I'm changing this one, series 1. I'm renaming it to midline and I'm changing the location to midline. And I'm going to add a second series, name it endline, and then I'm changing the location to endline. And then I'm going to add a third series and I'm going to name it developing flow or developing region. And I'm changing that to developing flow and clicking apply. Sorry, change the x-axis variable to velocity u and then the y-axis variable to just y. And then click apply again and you should get a chart that looks like this. And the reason you can only see the developing region is because the midline and endline are under. They are overlapping. Next, we're going to go back to the workbench. We are going to close out these. And we're going to right click on this and we're going to duplicate it because we're using the same geometry. So you can rename this if you want to Poisson flow. I think I spelled that right, probably not. And then the next flow we're going to be doing is Couette flow. So because we're using the same geometry, we can just jump right into the setup, double click that, and make sure once again double precision is selected and select start. Wait for this to load. And once that's done, we can select OK. So once again, we're going to go to Materials, Fluid. We're going to double click Air. And we're going to change our viscosity from 1e to the negative 5 to 1e to the negative 3. And then we're going to click, make sure your density is 1 again, and then we're going to click Change Create and close. And then we're going to click the drop down for boundary condition, and we're going to select Inlet, and then double click on this. And we're going to go down to sorry, we're going to right click on Inlet, and we're going to go down to Type, and we're going to change this from Velocity Inlet to Pressure Inlet. And we're going to check this off, Prevent Reverse Flow. Apply and close. And then we're going to click on the drop down for wall, and we're going to double click on lower wall. And we want these to be checked off again, stationary wall and no slip. Apply and close. And then we're going to double click on upper wall. And because this is Couette flow, we no longer want it to be stationary. We want it to be moving. So we're going to check moving wall. And we're going to change the speed to 8 meters per second. Apply and close. Now we're going to double click on reference values and we're going to compute from inlet. And we're going to make sure the reference zone has surface body selected. Once that's done, we're going to double click on initialization and we're going to click initialize. And once that's done, we're going to double click on run calculation. We're going to change our number of iterations anywhere from 300 to 500, and we're going to click calculate. Wait for this to calculate through the iterations. And once the calculation is complete, we can go back to Workbench and we're going to double click on results. And once we have this, we can go to the top and go to chart viewer and create new chart. It'll be named chart 2. I guess we can name it velocity profile for Quet flow. Click OK. Okay, we're going to click on data series. And we're going to rename this series 1 to midline, and we're going to change the location to midline. Then we're going to add a second series and name it endline, and change the location to endline. Then we're going to change our x-axis to velocity u and our y-axis to y, and then click apply. And we see this linear function with our max velocity at 8 meters per second, just like we set. And then we can go back to Workbench and close out these. Nope. And last but not least, we can do the hybrid flow. We're going to duplicate this one last time since we're using the same geometry. And we can rename this to hybrid flow. And then we're going to double click on setup. Once again, make sure double precision is selected and then click start. Once that's done, we can do the same thing as before. We're going to select materials, fluid, air. We're going to make sure our density is 1 again. And we're going to change our viscosity to 1e to the negative 4. And we're going to click change and create and then close it. Next, we're going to go to boundary conditions, inlet, and we're going to change our, double click on inlet. Okay, we're going to go to boundary conditions, select the drop down inlet. We're going to right click on inlet, and we're going to change the type from pressure inlet to velocity inlet. Then we're going to change our velocity magnitude to 0.8 meters per second. Click apply and close. Next, we're going to make sure our lower wall is stationary with no slip selected. And then we're going to double click on our upper wall, and we want to make sure it's moving, and we're going to change the speed to 0.6 meters per second. Click apply and close. Then we're going to double click on reference values, and we're going to compute from the inlet once again and make sure the reference zone is has surface body selected, and make sure the values that you entered are the same here. Then we're going to double click on initialization, and we're going to select initialize. And then we're going to select run calculation, and we're just going to calculate it. And once the calculation is complete, we're going to go back to Workbench. We're going to double click on results. And once again, here's our contour with our geometry. And now we're going to select location and then line. And we're going to name this underdeveloped region. And we're going to make our points for this length. We're going to do 45 millimeters. You might need a different length or different values for your points if your length is different. You want it before the midline. And we're going to change our Y value to 10 millimeters and click apply. And wait, we're supposed to change this to 100. Now click apply. And now we're going to add a new chart. Okay. Title, this is going to be velocity profile for hybrid flow. And now we're going to go to data series, and we're going to create two more data series. This first one is going to be midline, and the location is going to be midline. The second one is going to be end line. Change the location. And the third one is going to be that new location called the developing flow region. And we're going to select that new line we created. And finally, we're going to change our x-axis values to velocity u and our y-axis values to y just as before, and we're going to click apply. And here's the chart for the last velocity profile. Thank you.